on lab 6.03, which is labeled lab 20, on page 69 in your lab book. On page 70, there's a very important chart here that's going to help us make decisions about our 4 unknown mixtures. We have salt water, baking soda and water, chalk dust and water, and milk, which is primarily water. We're going to make some decisions based on some simple tests in part A, B, and C. Part A is just putting the solids into the liquids. In part A of the lab, I added 150 milliliters of room temperature water to 4 different containers. I did not use 300 milliliters of water because it was too much to fit in the container. I used half a tablespoon, that's a teaspoon plus half a teaspoon, of salt. And this is what happened to the salt. You don't see salt sitting at the bottom of the container. Salt, by the way, that you put on your popcorn is sodium chloride. There's lots of different salts in chemistry, but the one that we eat is sodium chloride. Baking soda, I put a tablespoon and a half. That's sodium bicarbonate. You can see that it's got Na, that stands for sodium, H for hydrogen, C for carbon, and 3 oxygen atoms. That's sodium bicarbonate. That's what you put in your muffins to make them a little fluffier. There's really not too much sitting on the bottom, a little bit, but most of the solid that I put into the water is now not visible. This is just 300 milliliters of good old, plain old skim milk. And this is a teaspoon and a half of chalk dust. It comes in your kit, looks like this. I put this into 150 milliliters of room temperature water. You can see that after sitting for a while, there's a layer of goop at the bottom. That's the chalk dust. If I shake it up, it looks like this. If I leave it alone for a while, it gets a layer of chalk dust on the bottom. So we can make some conclusions about what kind of mixture the chalk dust and water makes. It settles out the particles that we put in the solution, in the mixture, excuse me. The particles that we put in the mixture have settled out. The milk is another story. When I added milk to vinegar, it got all chunky, lumpy, and kind of nasty looking. You can try this one at home. Add a tablespoon of vinegar to a tablespoon of milk and see what happens. It kind of looks like spoiled milk. This is a colloid. When we add acid to some suspended particles, they clump up, and that tells us it's a colloid. When I added salt water to the vinegar, nothing really happened. We just got salt water and vinegar. No bubbles, no chunks, no lumps, no color changes. I'm going to assume salt water is not a colloid. When I add chalk to the vinegar, it gets kind of white, but there's no bubbles and there's no fluffy or chunky parts. So we're going to assume this is not a colloid. The chalk mixture is not a colloid. You can hear the fizz of the baking soda. There's a chemical reaction here because gas is released and there's lots and lots of bubbles. But there's no lumpy, fluffy chunks that would indicate there is a colloid. In part B of the lab, I've taken a tablespoon of white vinegar and added it to each of these cups. Then I have taken a tablespoon of each of the mixtures and added it to the cup. We'll look at what happens to each of the cups in just a moment. In part C, we're going to continue to work on this chart, which is in page 70 in your lab book. We've got a lot of unknown solutions. We check to see if they settle over time. That means a suspension. And we check to see if it got lumpy or fluffy masses when we added vinegar. If that was yes, that was a colloid. If it was no, it's a solution. Now we're going to work on checking to make sure which ones are solutions. In part C of the lab, we're going to check for the effect of temperature on solubility, and we're going to check and see if we have some solutions in our among all of our mixtures. I put all of the mixtures in a plastic box full of ice, and you can see that some of them have changed. The salt water, when it cooled down, the saltwater solution now has some solid on the bottom. So the solubility of the sodium chloride, the table salt that we used, has changed when we changed the temperature. And that is a characteristic of a solution. Same thing happened to the baking soda, the sodium bicarbonate that we used. You can now see that there's some solid on the bottom of this container. So when we cool down this solution, some of the solute, the baking soda, came out, is no longer dissolved in the water, and now it's at the bottom. When we cooled down the milk, nothing really happened. But does anything usually happen when you put your milk back in the refrigerator? The chalk stayed the same. Yes, it has solid on the bottom, but it had solid on the bottom when I put it in the ice. On the last part of part C in the lab, we've taken our two solutions, baking soda and sodium chloride, and we've run them under hot water to heat up the mixture. And we found that the solid we saw on the bottom before is now gone. So the solid that came out of the solution is now back in the solution. It's now been dissolved. So these two are solutions.